Around 4 billion years ago, Earth was not a living planet. There were no oceans full of fish, no forests, no bacteria, and no oxygen rich air like today. Instead, Earth was a violent chemical world of volcanoes, lightning, ultraviolet radiation, and oceans filled with reactive molecules. Yet, somehow, from this chaos, the first self replicating systems emerged, and eventually the first cells. The question scientists still try to answer today is simple but extremely deep. How does non living chemistry become living biology? I have discussed this question in the previous videos too. The early Earth environment. Modern research agrees that early Earth had conditions ideal for prebiotic chemistry, such as liquid water from oceans, active volcanism, and hydrothermal vents, a reducing or partially reductive atmosphere, constant energy sources such as UV light, lightning, and geothermal heat, continuous chemical cycling of elements like carbon, nitrogen, sulfur, and phosphorus. Recent studies suggest multiple possible cradles of life, including deep sea hydrothermal vent systems, warm surface ponds with wet dry cycles, volcanic continental rift zones, and impact generated hot spring environment. Each of these environments could produce complex organic chemistry. Before anything alive existed, Earth had organic building blocks such as amino acids, which are protein components, nucleotides, and RNA and DNA, lipids, and membrane forming molecules. Modern experiments show that these can form naturally under early Earth like conditions, especially with sources of energy like UV radiation, lightning like energy, and hydrothermal chemistry. Even simple droplets of water and gas mixtures can produce life related molecules spontaneously. This is important because it removes the need of biology at the beginning, only chemistry is required. One of the strongest scientific models today is the RNA World hypothesis, as I talked about in the previous videos, if you want to check it out. It proposes that early life may have started with molecules similar to RNA because RNA can store genetic information like DNA, catalyze chemical reactions just like enzymes, self replicate under certain conditions, and simplified systems. Recent research supports that the idea that short RNA strands may form spontaneously. RNA may have existed before proteins and DNA. RNA rich environments could create early proto life systems. This leads to a key idea. Life may have started as self copying chemistry, not full cells. The next step is compartmentalization, the formation of boundaries. Fatty acids and simple lipids naturally form bubbles, vesicles, and membrane like structures. These structures can trap molecules inside, creating concentrations of chemicals, internal reactions, and primitive cell like environments. These are called protocells, not alive but closer to life than chemistry alone. Some modern models suggest that metabolism may have started in mineral rich vents. Early cells may have used natural metal catalysts before enzymes existed. The scientists currently debate two major pathways. The first pathway is the RNA first model. Genetic molecules RNA come first, replication drives evolution. Another, a major pathway is metabolism first model. When energy cycles and chemistry networks comes first, life emerges from self-sustaining reactions. Modern research increasingly suggests that both might have worked together, not separately. Chemical networks likely formed first, then genetic systems evolved on top of them. At some point, protocells crossed a threshold. They gained stable membranes, self-maintaining chemistry, genetic information systems, and evolution through selection. This marks the emergence of first true biological cells, ancestors of all life today. All modern life tracks back to the last universal common ancestor, as an abbreviation for its name, called LUCA. LUCA was overly complex, meaning life likely started earlier and simpler. Even with strong progress, key questions remain. Did life begin in oceans or land pools? Was RNA first or metabolism first? How exactly did replication begin? Was there one origin or multiple failed origins? Science does not yet have a single confirmed pathway, but it does have something powerful: multiple plausible, experimentally supported routes from chemistry to biology. The origin of life is not a story of sudden appearance. It is a gradual transition from chemistry to self-organization to protocells and biological evolution. Modern science does not fully solve the mystery, but it strongly shows that life does not require magic. Life can emerge from natural chemical processes under the right conditions. And you're getting closer to understanding how it happened.